Okay, we're going to look at the volume here of a solid that's rotated about the line x equals 1, bounded by x equals 0, y equals x cubed, and y equals 1. This time I want to take a look at this bounded region by using the washer method. So where I want to start is with getting a rough sketch. This is the same situation for every volume that we do. Here we have our line y equals x cubed. Here we have our line y equals 1. And here we have our line x equals 0. So we've created this bounded region that will form a solid once we get it rotated around this line here, x equals -1. Okay, so as I stated before, I want to use the washer method this time to find this volume. When using the washer method, we know that our fundamental rectangle needs to be perpendicular to the axis of rotation. So in this case, we have a delta y. The first thing I'm going to determine is outer radius. Outer radius will be the outside of the solid when it's rotated about that line x equals -1. So the outside of the solid is going to be this edge. Use capital R to represent outer radius. So the distance from that edge to the axis of rotation. So I know in this case, capital R, or outer radius, is the curve in terms of y, so y to the 1/3 power minus a -1. Inner radius. We know that is going to be from a point on the line on the inner radius to the axis of rotation. We use lowercase r to note that. It's lowercase r in this case. Right minus left again. So we have the line x equals 0 to axis of rotation. So we have 0 minus a -1, which we know that equals 1. Now we can look at that. We know we have a vertical line, and we can plainly see that that line is parallel to the axis of rotation, and the distance between the two is always 1. Okay, next, let's set up our definite integral to evaluate the volume. So we know volume equals pi 0 to 1, outer radius squared, y to the 1/3 plus 1, quantity squared, minus the inner radius, 1 squared, dy. Use algebra, FOIL, subtract 1, combine like terms, integrate, plug in our upper limit, subtract it from our lower limit, and then we have the volume rotated about the line x equals -1.